Good afternoon, dear students. So let's have a quick recap of what we have learned yesterday in the basics of telephone system with respect to the subject communication systems. Okay. So yesterday we had learned about the basic telephone set, the internal circuit diagram, which is visible on the screen. That is, we had the local loop. So what is a local loop? Can anyone just tell me what is a local loop?
The connection between one telephone and the local exchange.
See, are you able to hear me? Dear students, are you able to hear me?
Yes, ma'am.
Yes, ma'am.
Okay. Can anyone tell what is a local loop? So local loop is a twisted pair of cable that runs from the telephone instrument to the local exchange or the company who is providing the service. Okay, so that is called to be local loop. So it will be in a twisted pair connection, and the local loop will be made up of, that is coaxial cables. So that is connected to the ringer circuit, hook switch, and these are the dialing circuits. And one more important terminology, that is hybrid. So this hybrid is the one that converts the 4-wired line from the handset to the telephone instrument, which is the 2-wired line. Okay, so some of you asked what is that is the DT. Are you able to see the screen? Okay, so now yesterday somebody asked what is that DTMF frequency. So how these frequencies are working, and why do we need to identify, that is how the different frequencies are identified, and what is the necessity of frequency generation circuit. Okay, so these are this horizontal line, all the buttons will be having a frequency of 697, and this next line 456 will be having a frequency of 770, and so on. And vertically in column wise, the frequencies, the higher group frequencies are 1209 and 1336. So I just wanted to show you a small video clipping of this, how this frequency is working. One second, let me share the screen with the full audio. Okay. Are you able to see the screen? So it is a small clipping that explains the DTMF operation. I just wanted to show you, everything is available in the net. I have not produced on my own. Just I wanted to show.
Go ahead. You can dial a number on that one. You've used that, I assume. You've heard that before? Mm-hmm. What'd you do, dial your number?
No, I just dialed the number.
Okay. Well, I've rigged it up so that I have a little pickup here, and it goes down to an amplifier so we can hear it in the speaker. Now, you've probably never done this before, but dial a very unusual number, 12, but do it both at the same time, 1 and 2. That would be 3.
See, now the boy has pressed the buttons 1 and 2 simultaneously. So it is producing a kind of sound. It will be something like 1 plus 2, 3. Okay, same way, let us...
Did you hear that?
Yes.
Try it again. Does that sound like anything you've heard before? There's that, but here's this.
It sounds kind of like it's mixed.
Like it's mixed? Try 2 and 3. Now try 2 and 1.
It's the same tone.
Yes.
See, when they are pressing 1 and 2 as well as 2 and 3, we are able to hear the same tone, because the horizontal row will be having the same signal which is having the same frequency. So same frequency of signal will be generated. Okay. Okay. Now let's again follow.
Go ahead.
That.
What'd you do, Don? I have a little pickup. You've probably never done this before, but dial a very...
Yes.
There's that, but here's this.
It sounds kind of like it's mixed.
Like it's mixed? Try 2 and 3. Now try 2 and 1.
It's the same tone.
Yes. Aha.
So each row has its own tone.
Has its own tone. This way.
Yeah, does it work this way?
Try it.
See, this vertical rows also will be having different frequencies.
Yeah, it does work.
Okay.
Okay.
So now each
But in a
key
single
in
column,
this
we'll
row
be having a single
has
frequency.
its own tone. Now push 1 again. Now listen very carefully.
It's the two tones mixed.
Yes. So when you push any key, you're combining the tone from its row in each direction.
So when you press 1, it will be automatically
Go ahead. You
like
Has
pressing
its own.
the combination of the vertical and the horizontal row.
Yeah, it does work.
Okay. So now each key in this row has its own tone. Now, in each direction. And that's what you're doing when you do that touch phone. And that's why it sounds that sort of strange, sort of funny sound, because the engineers decided that if they're going to send this sound over the wires, they should make sure that they send a sound that you wouldn't hear in everyday life. So they chose real odd frequencies, 4,297, all kinds of different things like that, to put into each row. And then they said, we'll make it even more odd, but we'll combine 2 of them. And that's what you're doing when you... Now would you dial a special telephone number for me?
All right.
621-2666.
It's very had a little loud.
You can finish it up by just using 6-2 there.
Okay, so that is about the DTMF frequency. So do you have any doubt in this? Yes, sir. Somebody has raised hand? Yes. Do you have any doubt in this concept? See, students, you can unmute yourself and you can ask. If you don't have any doubt, we can continue with the next topic. Okay, we'll continue with the next topic. Okay? Okay, sir. So that is about the DTMF frequency. Now let's get started with the next topic. Okay. So we had seen about the introduction of the telecommunication, and we had seen in detail about the standard telephone and the local loop and the detailed circuit diagram of that. So in today's class, we will learn about the electronics telephone and how these electronics telephones are assembled and what are the inbuilt components of an electronic telephone and how it is working. So we will see that in today's class. So hope you have understood the previous concept which we had discussed yesterday. That is the standard telephone and the local loop. Okay. So now let's get started. So this is the ancient, the telephone which was used in the olden days. And this is about the normal telephone landline which was used in the late 1980s, 50s to 80s. And this internal structure we had learned yesterday. That is about the standard telephone. And this is nothing but the electronic telephone, and this is nothing but your cordless telephone. So in today's class, we are going to learn in detail about this electronic telephone. Okay. So now let's get started. So this picture shows something about the latest electronic telephone, which has all these features. We will be able to communicate, send messages, and we will be able to, store messages, and caller ID information can also be retrieved. Call history can be done. All these options are available in this latest electronic telephone. And even the latest telephone, we are having some kind of portable telephones, that cordless telephones will be having the GPS operations, and we'll be able to connect it to the cloud network or any other kind of Wi-Fi network, and all those options are also available. So now let us learn how the electronics telephones are built up and what are the internal components of it. Okay. So now let us see how these electronics telephones have evolved when we were using that analog telephones. So with the evolution of solid state circuits in the late 1950s, these electronic telephones have come into the market. That is, solid state circuits means that integrated circuits. So yesterday we had seen some standard telephone, that is PCB circuit, over which all the components, resistor, capacitor components, for amplifiers, oscillators, that's crystal oscillators, diodes, have been placed on a PCB board. So now that is about the standard telephone. So all these have been converted into the IC level. That is with the help of this solid state circuits technology, it has been converted into an integrated circuit, and that is embedded on a single chip. So with that evolution, we have come to the standard electronic telephone. So that is the benchmark or the initiation of the development of the innovation of this standard electronic telephone. So well, you all know that simultaneously you are learning the subject, what is that? Analog integrated circuit, ASC. Okay, so how these integrated circuits are being developed, and what is the equivalent IC circuit conversion of normal analog devices. So that is what you're learning here. So with the evolution of this IC technology, we are able to develop this standard electronic telephone. So today, all new telephones are electronic in nature, and also they use the integrated circuit technology. So how it is happening? We are making this, what is the development of this standard electronic telephone with the help of a microprocessor also. This microprocessor, I think only now you will be learning, that is what is a microprocessor and microcontroller. So these microprocessor, microcontroller are the, what is the chip level processors that will be helping to perform so many operations. Like we are able to store the data, we are able to retrieve the data, we will be having a external memory in the microprocessor and the internal memory in the microcontroller. All these operations are possible with the help of this microprocessor. So the development of this microprocessor has also affected the telephone design. And although simple electronic telephones do not contain a microprocessor, and most of the multiple line and full feature telephones do. And this built-in microprocessor only permits the automatic control of all the telephone functions which are available in the standard electronic telephone. So some of the features include the telephone number storage, automatic dialing, and the redialing that are not possible in conventional telephones. So this automatic dialing, number storage, and redialing, most of us would have come across because we use it in our day-to-day life. Okay, so all these are the electronic components which we use in at our home. Okay, we have come across. So now let us see in detail what are the internal components of that. So most of the functions are implemented with the help of this integrated circuit technology. So everything is in the form of IC. That is why even the size of all these components are being small. Okay, and we have the touch tone keypad that drives the DTM of tone generated circuit. So yesterday we had seen that is DTM of tone generated circuits with the help of the push buttons that were driven by the analog circuits. But here, in case of this electronic telephone, we will be having the DTM of tone generator with the help of the touch tone keypad that will be controlled electronically by an oscillator. Okay, so that oscillator is going to be a ceramic resonator that will be generating the corresponding frequency of signals, and thereby it is what is identifying the number that is being dialed. And this tone ringer is driven by a 20 Hertz ringing signal from the telephone line, that is from the central office, and that drives the piezoelectric sound elements. So yesterday we had some kind of a ringer instrument. We learned a ringer instrument that was helping in producing the ringing sound. Okay, so but here in this electronic telephone, we have the piezoelectric sound element that produces the ringing sound whenever a call is being received from the telephone office. Okay. And this is a picture of the standard IC electronic telephone. Okay, so this is the detailed internal structure of a standard electronic telephone. That is a single chip IC, that is a electronic telephone. So this is the DTM of circuit. So where we have the keypad, that is the push buttons will be here, and this is connected to a ceramic resonator which will be generating the corresponding frequency of signals in order to identify the number that is being pressed. And we have the MPU unit. MPU unit is the microprocessor control unit or microcontroller control unit, depending upon the version of the electronic telephone design that is being developed. So this is going to have the inbuilt memory or some kind of RAM or RAM memory that will be helping to store the data. Okay, so you all must be knowing what is the difference between RAM and ROM. So RAM is nothing but the random access memory. It is a temporary memory, and ROM is the read-only memory. That is where all the programs, so all the control operations of the other circuits will be programmed with the help of this microprocessor. So that program will be stored in the ROM memory, that is read-only memory. Only the manufacturer will have the access to ROM memory. So there will be pre-programming. What are the operations this particular instrument should do? What are the control operations? And whenever a particular signal is received, what are the operations that it should have, that it should perform? Everything will be pre-programmed by the person who is going to manufacture this instrument. So that will be pre-programmed, and that program will be stored in the ROM memory. Okay, and this RAM memory is a random access memory, the temporary memory, wherein your temporary call details, all these details will be temporarily stored. So when power goes off, sometimes you will be losing the memory. Okay, so that is the random access memory. That is the difference between ROM memory and RAM memory. Okay, so this you should know. This is a very basic information. As an electronics engineer, you should know. Okay, and next one is the tone ringer circuit. So this is the one that is going to give a ringing sound whenever a call is being received. So this ringing sound is we are able to here when a piezoelectric, with the help of the piezoelectric sound element. So that is connected to the local loop via a diode D1, that is a xenon diode D1 and D2, through a bridge rectifier circuit to the local loop. So this local loop, it is going to be the tip and the ring. Okay, this is local loop is going to be the tip and the ring. So it is connected via these diodes and the bridge rectifier circuit. So whenever a call is being received, all these circuits will be activated and the ringing sound will be created with the help of this piezoelectric sound element. So now I will explain. Now just I am explaining what are the blocks and components of a standard electronic telephone. I will explain in detail how this circuit is functioning. Okay. Next one is the speech network. So it is the speech conditioning network, which is going to work on the audio signals that is being received with the help of the microphone. So whenever we speak, that will be captured with the help of the electric microphone. So that will be captured here and that will be conditioned. So if any extra additional noise has been added, all those information will be nullified with the help of a filters that is available in the speech networks. As well as whenever somebody is speaking, we will be able to hear with the help of the speaker, that is the receiver. So whenever some noises have been added, that will be rectified, and some amplification. So some low voice, we could sometimes speak at low voice, and that will be amplified so that it is clearly audible. So those process will be done with the help of this speech network. So it is going to have a simple DSP circuits, that is signal processing circuits. Okay, and the voltage regulator. So it is the one that is going to supply the DC voltage for all the components to function, is it not? So we need a supply, power supply, DC power supply for all the internal circuits to get activated. So that is done with the help of a voltage regulator, and that is also connected to the through the local loop to the D3. So for whenever signal is being received, that is connected here. And also we need a additional power supply for this standard electronic telephone. Okay, so sometimes power adapter will be there. Okay, this electronic telephone will have power adapter that supplies power to this electronic telephone. Okay, and now let us see in detail. So what is the function of the voltage regulator? So this IC also contains a built-in voltage regulator. It takes the DC voltage from the local loop and stabilizes it to provide a constant voltage to the internal electronic circuits. Well, you all know that the functionality of a voltage regulator. What is the functionality of a voltage regulator? It regulates the voltage. So it is nothing but a stabilizer. Okay, you might have done an experiment in EC1 lab, I suppose. So whenever there is a voltage fluctuation is there is high and low voltage, everything will be rectified and regulated, and you will be having a constant DC voltage that is supplied to the circuit. So the best example of this voltage regulator, what we use in our day-to-day life, is the stabilizer. Okay, so why do we use a stabilizer for our electronic components? Your air conditioners, your television, your washing machines and refrigerators, we use regulators. Why? Means all the circuit components which are being the IC part are all sophisticated, are all expensive. And these components should not be torn off or should not be burnt when there is a voltage fluctuation in the AC voltage that is being received at our home. So this voltage fluctuation is nullified with the help of this voltage regulator or stabilizer. Therefore, the output of this voltage regulator will always be a constant voltage. So do you have any doubt? Somebody has raised hand. Emma Malini. So please unmute her, sir. Emma Malini. Emma Malini, do you have any doubt? Hema Malini? Hema Malini, register number 84. Do you have any doubt? Yes, ma'am? So if not, we can continue. Do you have any doubt? Okay, sir. Thank you. And that is about the voltage regulator. So this, what is the internal component of voltage regulator? It is going to be an Zener diode and a transistor which provides bias to the electret microphone, and that is connected here. Okay, that is connected to the handset. So whenever a signal is being received, that is connected to the handset, and we will be able to speak as well as receive the signal. Okay, this is about the voltage regulator. Next, we will see the speech network. So the internal speech network contains a number of amplifiers. As I told you, this speech network is nothing but a conditioning circuit. So it is going to condition the signal, audio signal that is being transmitted via the telephone network. So it is going to have amplifiers, and related circuits means the filters, okay, that fully duplicate the function of a hybrid in a standard telephone. That is also going to perform the same function as a hybrid. So what is a hybrid? It converts the 4-wired line from the handset to a 2-wired line, that is the twisted loop, which is getting connected to the local loop, that is the to the telephone exchange. Okay, so it performs the same operation as that of a hybrid. So that is the functionality of the speech network. Next one is the microcomputer. So this is an IC which provides the microcomputer interface, and this box labeled MPU is the single chip microprocessing unit. Although it is not necessary to use a microprocessor, if an automatic dialing or other functions are implemented, then the circuit is capable of accommodating them. Okay, so this microprocessor will have an external memory, whereas if you are using microcontroller, it will have an inbuilt memory wherein the data will be stored there. So, and it will be having control over all the other circuits. So everything will be in the form of integrated circuit IC. Okay. Now let us see finally the bridge network. So what are this bridge network? What is the functionality of this bridge network? So under hook switch. So the bridge network, through this bridge network, it is connected. There is the other circuits of this electronic standard telephone is connected to the bridge network, that is via the hook switch. So the twisted pair from the local loop is connected to the tip and ring of the wire. So both 48 volt DC that is coming from the local loop and the signals, that is the ringing voltages, that is for 20 hertz, which has been that is being received when a call is being received, that will be received from the telephone exchange via the local loop. So that is applied to this bridge rectifier circuits. So that will be connected to this tone ringer circuit, and we will be able to hear the ringing sound. And based on this is at the moment when you are placing the handset on the telephone. That is, it will be in the open circuit condition. After the call is being received, you have to lift the handset, and then you will be starting to talk, and it will be in a closed loop condition. So that functionality we will see in detail. So this is about the hook switch and the bridge rectifier circuit. So this is how it is connected. Okay. Now let us see the detailed operation, how it is working. That is, whenever a call is being received, that is whenever it is in the off, or that is when a hook switch is on the handset, the circuit will be in an open loop condition. This we have discussed yesterday itself. The same is the case for the electronic telephone also. So in the detailed circuit, when it is in the on hook position, what is that? It will be in an open loop circuit. So this hook switch, which is connecting the bridge rectifier circuit to the diode D1 and D2, that is to the ringer circuit. Okay, and this is connected to the telephone line. So whenever a call is being received, it will be this resistor R1 and C1 will be rectifying the circuit here, and that rectified voltage will be making the hook switch in this position, and that will be activating the diode D1 and D2 and the tone ringer circuit. So this, whenever this tone ringer circuit is activated, what happens? Automatically it produces the sound with the help of the piezoelectric sound element. So that we will be able to hear the ringing sound, indicating that a call is being received to that particular telephone instrument. Okay. And as soon as we hear the ringing sound, what we will do? We will lift up the handset. So when we lift up the handset, what happens? The hook switch will be moved to this position here. Okay, so at that time, there will be a rectified circuit. This rectified circuit will be sending a pulsating voltage to the diode D3, and therefore that will be activating the voltage regulator. So this voltage regulator, with the help of this biasing circuit, that is the transistor, it will be supplying voltage to all the other components in the electronic telephone instrument, that is the DTMF circuit, the speech network, and the MCU unit. So it supplies the constant DC voltage. So when this constant DC voltage is supplied, we will be able to hear the person, whoever is talking, will be able to hear the audio sound. So this is how it is functioning. So again I tell, that is whenever you keep the hook switch on the handset, it will be in a open loop condition. So it will not be physically connected. But the hook switch will be connected from the bridge rectifier circuit to the tone ringer circuit via the diode D1 and D2. All these are Zener diodes. Okay, D1 and D2. And then we will be able to hear the ringing sound. So after hearing the ringing sound, we will be lifting up the handset. So while lifting the handset, what happens? Automatically, this hook switch will come to this position, and the voltage that is coming from the telephone exchange via the tip and the ring will be rectified this bridge rectifier circuit, and it will be activating the voltage regulator, which supplies there will be voltage drop here. Okay, 5 to 6 volts. That will be activating so that is all the other circuits present in the electronic circuit. Okay, so for some people who have not followed, this is the one. So this is the operation. That is, whenever AC ringing voltage is applied, bridge rectifies into a pulsating DC voltage. So the hook switch is shown with the telephone on the hook, which is in the hung up position, which means that it is in the open loop condition. Thus, the DC voltage is not connected to the circuit at this time. Okay, and the AC ringing voltage will be coupled through the resistor and capacitor R1 and C1, where it will be rectified and applied to the two Zener diodes Z1, that is D1 and D2, and the tone ringer circuit will be activated, and we will be able to hear the ringing sound. Next, when the telephone is taken off the hook switch closes and provides a DC path around the resistor and capacitor R1 and C1. Therefore, the hook switch will come to the other position. The tone ringer circuit is broken. That is, the loop from the tone ringer circuit is broken, and hook switch will come to the other position, and the output of the bridge rectifier circuit is connected to the Zener diode D3 and the line voltage regulator. Thus, the circuits inside the IC are powered up, and the calls may be received or made. So this is how the operation of the electronic standard telephone is working. Okay, so do you understand? Shall we move on to the next topic? So it is a very important one. So this diagram you have to draw, and you have to explain in detail. Also, all the internal functionalities you should know in detail as an electronics engineer. Okay, so what are these rectifier circuits of for this diode D1, and what is a voltage regulator, and what is its functionality, and what is a speech network? The speech network, it is going to just implement a signal processing, DSP processing, signal processing for filtering, and there will be some amplifiers for amplifying the sound. Okay, so these are the basic operation of a standard electronic telephone with a detailed circuit explanation. Okay, hope you have understood. So that is about the operation of the standard electronic telephone. So all the circuits will be powered up by the voltage supply that is coming from the telephone exchange through the local loop, and it will be powered up. Okay. And coming to the microprocessor control, so all the modern electronic telephones will be having a built-in microcontroller. So well, you all know that the basic difference between microprocessor and microcontroller. So as you have not studied about a microprocessor and microcontroller, let me also tell the difference between a microprocessor and microcontroller. So microprocessor is the one that is It is going to perform various operations. That is your arithmetic and other all other mathematical operations that has been developed, which is going to be the integral part of the CPU. That is a central processing unit of a computer, microcomputer. So this microprocessor was first developed for performing all these operations, all mathematical operations in a CPU of a computer. So this microprocessor will be doing only those operations and it will not have any memory. So later this has been developed as an integrated circuit with the evolution of the VLSI technology and your IC technology. So it has been developed into an integrated circuit. And the main difference between microprocessor and microcontroller is that this microcontroller also performs the same operation as a microprocessor, but the main difference is this microprocessor will not have the memory in it, whereas this microcontroller will have an inbuilt memory on the chip itself. And also the peripherals could be easily connected here in case of a microcontroller. And if you wanted to connect, that is communicate with the other peripheral devices, external devices, we need to make use of the external buses for connecting the peripheral devices to the microprocessor. So these are the main differences between the microprocessor and microcontroller. On all your advanced computers and the Intel Pentium processors will be having the microcontrollers only. So that you will be learning in detail in next semester about the microprocessor and microcontroller. So I just wanted to have a brief information about the microprocessor and microcontroller here, because we are making use of this microcontroller in our standard electronic telephone. Okay, so like any microcontroller, it consists of a CPU, that is the central processing unit, and a ROM, that is a read-only memory, that will be inbuilt on the IC itself. So this ROM is going to have all the control programs, and as I told you before, the manufacturer will be storing all the programs, okay, all the commands, instructions, or what this particular microcontroller should do. Everything will be programmed and inbuilt, and that is stored on this ROM memory, read-only memory on the microcontroller. And a small amount of random access memory will also be available for the temporary storage. Like if you want to store our data information, like the call history and some there is caller ID information, whatever the call being received, and some numbers, some 5 to 10 numbers also we are able to store. That is with our close friends which we are frequently calling, that numbers could also be stored with their name. Okay, so all those things will be happening here, and also some of the input-output circuits. And this microcontroller is usually a single chip IC. Again, it is an integrated circuit that may be directly connected to the telephone IC, or with help of some intermediate interface circuit may be used. So if it is going to be a single chip IC, all the things will be integrated on that. That is some kind of advanced telephones and sophisticated telephones wherein they use for this VoIP calls and other advanced applications. They'll be having a single chip over which everything will be integrated. But some standard telephones and conventional telephones, they'll be having a separate microcontroller chip, and all the other interface circuits will be connected via buses. Okay, so these interconnections, all these via connections, everything you will be learning in the next semester. And the functions performed by this microcomputer include the keyboard control, or any LCD display. That is, whenever a call is being received, we will be able to see the caller ID information, or the person whom we are calling, dialing, everything will be displayed on an LCD display. So all this will be communicated. So this microcomputer is going to perform all these control operations, and the storing of telephone numbers and automatic redialing. Is it not? That is, we dial some number, the person line is busy and he's not picking up. You press one button, the redial button, automatically the number will be redialed. We need not dial it again. This concept we know. Okay, and this also it will be having some microcontroller RAM where you will be storing the temporary information. And other features implemented with the help of this microcontroller are the caller ID and the answering machine. There is a automatic answering machine is also there. Okay, and also call diversion machine. So some kind of voice will be able to hear if automatic answering machine is being enabled. So for that we need to get a prior permission from the subscriber who is providing the telephone service. We have to register to them, and also we'll be billed for that particular method also, process also. Okay, for getting the caller ID specifications also. And this automatic answering machine, whenever the call is not being answered, automatically you will be what is that, there will be a person, like a kind of voice generated. So these voices are computer generated voices. Okay, it is called to be IVR, interactive voice response systems. Automatically it will be generated. So these voices are also computer generated with the help of this microcontroller, and it will be recorded. Okay, and sometimes we'll be able to leave the voice messages, is it not? There is voice messages digitized and the compressed and then stored in a small flash ROM. So we are dialing to a particular person, the person is not lifting up, so what you will be directed to make a voice message. So we can make a voice message, and this voice message will be converted to the digital information and will be compressed and stored in a small flash ROM memory. So after, whenever the person is reaching home, he will be able to receive the, look at the voice messages, and he can replay that and see whoever has called. And what is that? We can replay the voice messages, and it is a temporary flash memory ROM only. So it will be stored for some duration, and after some days, the voice messages will be vanished. So it will be erased. Okay, so that is called to be the flash ROM. Okay, and we have the outgoing messages also stored here. So if you want to leave some messages to particular some number, that is also going to be outgoing message. And we have the caller identification, as you all know that most of us are familiar with. It is also known as the calling line identification service, and it is a feature that is now widely implemented in most of the electronic telephones. As we have it in our mobile phone also, caller ID, true caller ID we have, is it not? Same way in the standard electronic telephone also we have the identification service. So to make use of this service, we must sign up with the subscriber who is providing the service and pay for it monthly. So with this feature, any calling number will be displayed on the LCD and read out when the phone is ringing. So this helps us to identify the caller. And the caller ID service sends the digitized version of the calling number to your phone during the first and the second rings. And the data transmitted includes the date, time, the calling number, and the data transmitted by FSK when a binary 1 is marked. And all these frequencies are being transmitted via the signal that is being received from the telephone exchange itself. Okay, so all this caller ID information will be coming along with the ringing signal that is being received from the telephone exchange itself. Okay, so coming to the message format, that is caller ID transmission format, there are two message formats in use, that is the single data message format and the multiple data message format. So these two signals provide initialization and synchronization of the caller ID circuitry in the phone. So it is a 1 byte information describing the message time. So for for indicating that it is a single data message format, the binary 4 is stored in that particular byte information. So well, you all are familiar with the kind of data information. It is not. You might have learned in your digital logic circuits, binary representation and hexadecimal representation of numbers. So the binary 4 is represented in an 8-bit format in this way. So that data will be transmitted via the signal. So indicating that the message format followed is the single data message format. Similarly, we have multiple data message format also. It is going to follow different protocol. Okay, so this is followed by a byte containing the message length, usually the number of digits in the calling number. So the next data is the data is transmitted, and the data is going to carry the information about the date, time, and the 10-digit number who is placing the call. And the phone number is the 10-digit phone number is transmitted as an ASCII bytes with the least significant digits first, because this microprocessor and microcontroller will not identify any physical numerals. So it will be able to identify only the data in a binary format, zeros and ones. So always we go for the hexadecimal representation of data. So this is, it has been programmed in such a way that it will be able to identify only the data in form of zeros and ones. So accordingly, we have to set the data format, okay, for a binary representation of the number that is being dialed or that is being received. So the data format is going to carry 2-digit information for month, 2-digit information for the day. Day means Monday, Tuesday. Each and every number will be uniquely defined, and a 2-digit information for the hour. So it is going to follow the military time, and military means that is not 12 hours time, it's 24 hours time. and the 2 digits for the minutes, and up to 10 digits for the number that is being called. That is or the calling number, the person who is calling. So that is going to carry the caller ID information. So this is the representation of the caller ID transmission format. It is going to be that is the SDMF format, that is the single data message format. So that is encapsulated in the ringing sequence. So we'll be able to hear the ringing sound, is it not? So between the first ring and the second ring, the caller ID data is transmitted. So this all these signals has to be transmitted via the local loop, is it not? Therefore, that has to be sent along with the ringing sequence signal. So this ringing sequence signal, yesterday itself we have learned, is it not? So in between the first ring and the second ring that is generated by the from the telephone exchange, that is the 20 Hertz ringtone, this caller ID information is encapsulated. So this is the detailed information of the data that is being carrying the caller ID information. That is, it's going to be kind of a data package. The data package is going to be zeros and ones. Okay, so that is going to carry this information. So this is nothing but the initial bits. So that is going to indicate that the data for caller ID is being sent here, and that will be a 70 milliseconds of pass, and that is followed by what is that? This one is going to be the message type. That is going to be an 8-bit information. So this 8-bit information, so it is going to here it is going to be for SDMF, it is going to be 00000100. It is going to be a binary 4. So that information is message type, indicating that it is SDMF. And next one is the word count. So what is the length of the number that is going to carry? It is going to be a 10-bit. So that 10 information also will be represented in an 8-bit format, because it is going to be all in zeros and ones. And next, that is followed by 144 bits. These 144 bits are nothing but it is going to represent a 2-digit for month, 2-digit for day, 2-digit for hour, and 2-digit for minute, and followed by the 10 numbers. So everything will be converted. So here physically I am showing the number as 2, 14, and day means the day. What is that? Date. Okay, and the hour, minute, and the what is that? Phone number, telephone number, the caller, person who is calling. So that will be converted to the corresponding binary bits. So when you count all this, it is going, so 0 will be represented as an 8-bit information, 2 will be represented as 8-bit information, this 1 will be represented as 8-bit information, and each and every number will be represented as an 8-bit information, and totally it is going to have 144 bits. So, and finally, what is that? Always any data packet that is sent will have a checksum. Checksum is nothing but, you might not be familiar with this terminology, checksum. So that is what we use in a case of data communication to find any errors as occurred. So this machine interaction, it is going to be just, it is going to send zeros and ones as the data information. It will not know whether it is receiving a correct information or a wrong information. So that has to be checked. For that, we send a following 8 bits of checksum. That is called to be cyclic redundancy checksum. That you will be learning in the next semester. Just you have a simple information checksum. So this checksum will be identifying whether the error has occurred or not whenever you are sending that information as a data packet. So automatically after the caller ID is being received, that will be displayed on the LCD screen. So there will be a circuit which will be controlled by this microcontroller for receiving these zeros and ones and converting it into the corresponding information like 02, 14, day is 14, 15 is the hour, minute is 37, and the number is, this is the number that will be displayed on the LCD screen on the electronic telephone. So these are the conversion processes happening. Okay. So this next one is the, so I think you have understood this concept. So it's a very important terminology, that is the caller ID transmission format. And only one last point is there, that is we have to, now these are the internal circuitry of the electronic telephone. Now we have to physically connect this electronic telephone instrument to the what is that, wired cable, which is terminated at a jack. Okay, so the terminated is nothing, the special connector on the cable is nothing called to be a RJ11 modular connector. So these are the universal standards that we follow. So normally we connect your monitor to the CPU with the help of this RS232 cable, and so many standards are there. So these are for connecting the standard electronic telephone to the local loop, we have the RJ11 modulator connector. So that plugs into the matching wall of the jack. So there will be a jack provision on the wall for where the local loop from the telephone exchange will be terminated, and we need to connect our instrument to that particular jack with the help of this RJ11 modulator. So this is going to be the wiring block and the modular interface, and there is a small plastic housing containing a wiring that connects the line from the telephone company to all the telephone wires in the house. So many houses and apartments, they will be previously, while building up itself, they'll be having the wires running internally, and this wall jack will be provided. Will have a provision for this wall jack in each and every room. And apart from this line from the telephone company usually passes through a protector that provides the lightning protection, because these wires are running through the ground, is it not? So sometimes it will be buried under the ground. So most of us would have seen some PBX racks, some wires, telephone lines are running. Okay, some repair operation they would be doing. That is that the wires will be running ground. So when it reaches home, so it has to also be protected, because directly we are connecting the instrument to the local, there is a local exchange via this local loop. So that should have some kind of lightning protection. So additional casing will be there, so that because these wires are going to carry some voltage information. So when it is directly subjected to this kind of lightning or thunder, what happens? It will be electrocuted, is it not? So in order to nullify that, in order to avoid that, all this lightning protector casing will be there. And if it then terminates into an interface box and RJ11 jack, and that is plugged to the connected to the rest of the wiring. So just this is the last slide. Just listen. So it is going to be the lightning protector, which is coming. There is local loop wires from the telephone company with 2 or more twisted. Everything will be inside that. Okay, an outer jacket will be having the lightning protector. That is the wires, that is cables. Okay, some kind of material that will be protecting the wires from the lightning, and this is the modular jack that will be terminating here. Okay, and to this we have to connect via the RJ11 plug connector. So if you are having landline telephone at your home, just you have a look at this RJ11 plug. So inside it will be having red and green. Normally, if you are having one line, it will be having red and green. And if we want to have a second line, that is, if we have another room also and we want to have an extension line, we will be making use of this black and yellow. So whenever a particular person is coming from the telephone exchange, they will be giving all these connections. Okay, physically they will be giving. And this telephone plugs in here. So to this, through this jack, what is that? We will be connecting the telephone instrument here. Okay. That is telephone instrument also will be having this twisted pair of, yesterday we have seen, is it not? One kind of plug connection that is connected here, and the other end of the wire is nothing but the RJ11 plug that is connected to the modular jack, which is fixed on the wall. So this modular jack is the terminated point of the local loop wire that is running from the telephone company. Okay. So this is about the subscriber interface. So via the subscriber, we are connecting it to the telephone exchange via the local loop with the help of this modular jack that is available on the wall. Okay, so this RJ11 plug connector. Okay, and this is the actual detailed pin connection. If you go closer look into that, you will be having all these details. So the main line, so it is going to be the main line. If you can have, so that will be kind of what is that? Some kind of device. They will be fusing the wires. These wires will be very thin. Okay, but it will be carrying the voltage information. So that will be some kind of devices will be there where they will be fusing it. Okay, and connecting these jacks. And this is the main line. It is going to be the ring and the tip information. Ring is always indicated by red color. This is some kind of color coding is there. Okay, so that it will be for us easy for us to understand which wire is for what. Okay, and this is the red is indicated here, and the green red is for the ring wire, and green is for the tip. Okay, you remember the local loop connection, it will be connected to the ring and the tip. Okay, that is the main line. So if you wanted to have a second line, you will have additional option also, the yellow and the black. Okay. So yellow will be acting like a ring, connector acting like a ring, and the black will be acting like a tip. If you wanted to extend the second line. So these are the wire connects, and this is the end view of that RJ11 connector. So the most of the telephone wires and RJ connectors will have 4 wired and connections, and if you are having only one connection telephone line, these lines will be used. Okay, this red and green line will be used. Only if you wanted to have a second line, these lines will be used. So it is just going to carry the voltage information from the telephone instrument to the telephone exchange via the local loop. Okay, so this is the physical outer appearance, and internally the local loop will be running. Okay, so that is what about the standard electronic telephone. Next, we will learn about cordless telephone in the next class. So as of today, we have learned about the standard electronic circuit, that is the detailed circuit of a, what is that? I just wanted to recall. So this is the detailed circuit of a standard electronic telephone, wherein you will be having the bridging circuit and the same concept as we have seen the standard telephone and the local loop, same concept, but it is advanced one. We have the microprocessor unit, and all this will be controlled with the help of this microprocessor unit. And we have learned how the signals are getting transmitted in the form of the that is the transmission format, SDMF format, as an example. Please suggest a book to refer, ma'am. So the book which you can refer is Frenzel, Louis Frenzel. There is a message from Mohan Sai. The book you have to refer is Frenzel. So that soft copy ebook I have, that will I will upload in the LMS. Okay, Frenzel, Louis Frenzel. In that, all these details are available for telecommunication. Probably Veera Lakshmi will be uploading the video in the LMS. Okay, we'll be sharing the video so that you can follow up there. Okay, dear students, we have come to the end of the class. Is the concept clear?
Yes, ma'am.
Okay, ma'am. So soon we will share the textbook, e-textbook, as well as the video what we have recording here. The presentation also we'll try to share. That will be helpful to you to follow up. Okay?
Thank you, ma'am.
Okay. Okay, ma'am. Thank you.